Hello, I'm Nobby Clark. Welcome to my workshop. Before I start my video, I'd like to send a message to one of my 2 subscribers. If you happen to be watching this video today, Tom, Mum and I would like to send you our best wishes for your birthday today. We hope you have a wonderful day today. Recently I've been making some more parts for my version of the Myfordboy Engine. 2 of the parts I made recently were the piston and the valve piston. Both of these parts require the same machining to the ends of the rods here. They both require a small hole to take the wrist pin and a slot machined into the bar here. This obviously you can do in the milling machine, and this procedure would be very easy to carry out if I had a DRO digital readout on the X and Y movement of my milling machine, but unfortunately I don't have that luxury. Now it would be very easy to hold a piece of stock in a V block like this, and that can be then dropped into the vise and the bar locked against one of the jaws of the milling vise. Some vices have V grooves already in them to hold round stock in place, but this one has smooth jaws on both sides. Even if you do this, you still have the problem of finding the absolute dead centre of the bar to drill the hole. Now there's a very easy way of getting round this. If you mount the V block upright in the vise, lock it in place, obviously tap it down so that it's held tightly against the parallels, and hold the bar in place with the clamp. But before you do this, use a little device like this. I made this up. It's a pointer that can be mounted into the drill chuck. Now the idea of this isn't mine. I saw this trick on David Ticehurst's video channel. So you mount this into the drill chuck, use the X movement of the mill to get this in roughly the centre of the V block, and then use the Y movement, moving the block backwards and forwards until you drop that exactly into the V groove. This is made, the pointer is made with a 45-degree angle here, obviously a 90-degree inclusive angle, so that can be dropped exactly into the V groove. Now once you've done that, you know that you've got the V groove exactly centered to the drill and the drill chuck. Once you've got that in position, lock the Y movement. Now you can move the X movement of the mill to bring the drill chuck over the edge of the V block. Now put your piece of bar into the V groove and lock it in place with the clamp. Before you lock that down, the ideal thing is to put a piece of material between the work and the bar so that you don't mar up the bar, because as one of these is actually a piston itself. Obviously you want this surface to be totally smooth. The other thing to do is to mark a witness mark on the end of the bar in exactly the position that you want the drill hole to be. You can, in this case it was 125 thousandths in from the edge. Now, to find the centre over the little witness mark, you can use either a thing like this called a wiggler. I prefer to use this little tool that I made. It's just a pointer, and I find this very much easier to use. Put that in the drill chuck and then move that over the bar, and then move the X movement of the mill along until that lines up with your witness mark. If you use a little magnifier as well, you can see very accurately this is exactly in line with your little witness mark. After you've done this, you're ready to drill the hole. Very important though to use a centre drill first, because you're only using, in this case, a very fine drill, and the danger is that the end of the drill will flex and skate off the surface of the bar. So use a centre drill to start the hole position off, and then drill through with your drill. Once you've done that, the next stage is to cut the groove in the bar itself. Obviously this is going to be done with a slitting saw, but again you've got a problem here of making sure that this also is in the dead centre position of the bar stock. Now, an easy way of doing this is that in my case, if you watched one of my videos a couple of weeks ago, you saw that I adapted a digital vernier gauge onto the Z-axis of the mill. Now, with this in, obviously changing the drill chuck for a collet chuck with the arbor mounted into the collet chuck, you very carefully bring the slitting saw down to the top of the bar. Make sure it's not over the hole itself, because obviously when you drilled through, you would have made a burr in the bar itself. So just do this on the very edge of the bar and bring that down. What you can also do is, and again another old machinist trick, is using a piece of cigarette paper between the work and the slitting saw. And this cigarette paper only measures about 1/1000th thickness, so just bring that down until that grips the cigarette paper. Once you've done that, zero the vernier gauge out, and then repeat the process on the underside of the bar. Now, take a note of the digital reading on the vernier gauge and half that reading, and then raise the slitting saw up until you reach that halfway measurement. Now you're clear to cut the slot in the bar itself to the required depth. Very easy process to do, and you can be guaranteed that the little hole here, which is for the wrist pin, and the slot here for the crank connecting rod to slide into, you can be guaranteed that they are absolutely central. Once you've done this, obviously you can remove the bar and then make all the deburring to the hole and the slot you've made in it. Well, I hope that information is useful to you. I've put a link below the video here in the description to David Ticehurst's channel. very interesting guy. He's a long-term machinist and puts on his channel lots of very interesting tips that he's learnt over the years as a machinist. Now I hope that some of you out there might be willing to join the 2 other subscribers on my channel. If you do, I'd be absolutely delighted and honoured if you did that. Anyway, thanks for joining me again in the workshop today. I hope to make another video for you very soon. Bye bye for now.